Okay, thank you so much for joining us today. We are Auxiliary Robotics. We're propelling assistive healthcare into the future. This is our called validation demo. So this is the team, Abhinav, Atharva, Shivam, Kavin, and myself, Charlene, and our advisors, Professor Zakshi Erickson. This is our project, Alfred, a friendly indoor robot that can provide low-risk assistance to patients in an elderly care environment and improve their health monitoring. So these are the things that we're going to cover today. First, we're going to tell you why we actually need Alfred. Then we're going to show you what can Alfred do, what we showed in SVD. And then how does Alfred work? We're going to proceed with the demo and then show you a little bit of a teaser about what we're going to do in Encore next week. So why Alfred? So nursing homes and assisted living facilities are constantly losing their caregivers. There's a labor shortage. And due to reasons like challenging work hours, inadequate pay, and this is being supplemented by a growing senior citizen demographic in the US, which is continuously expected to grow. And by 2040, you can see there are 80.8 million around the US. So there's a need for a long-term solution. So can you empower caregivers and reduce the mundane workload that they carry? So this is what we proposed in SVD. So you give Alfred a voice command, it interprets it, and then it fetches you objects. So it can navigate, it gets a path, and then it reaches the goal. After it reaches the goal, it starts searching for the objects. So here you can see it's searching for all the objects in the environment. And then the object of interest that the user requested for, in this case, a banana, it will go ahead and fetch it. And then it will bring it back to the user navigating the same path it did before. So this was SVD. We also showed some video calling capabilities in which the loved one or relative of the resident in the assisted living facility can essentially video call and also teleoperate the robot in the environment like this. How does all of this work? So we have three components: HRI, navigation, and manipulation. HRI is being used is using OpenAI Whisper. It's powered by ChatGPT, which allows you to give more than one parameter to ask for the same thing. Firebase is basically handling all of these primitives online. And Agora and Flutter are being used for our app and video calling APIs. So for navigation, we were using a 2D LiDAR for obstacle avoidance last time. We're still using that, but there's a big limitation to this. So of course, for objects that are well stationed to the ground and are not elevated, it can detect them pretty well and avoid them. But there's a big limitation to this. So essentially, if let's say we give it a path, it can reach a goal and it can plan its path dynamically around the obstacles. But these obstacles could be something like this. Now, the chairs that you're sitting on and chairs that you see in your environment, they have these 4 legs. And essentially, the LiDAR can only pick up these 4 bases. Not a problem for walls, not a problem for doors, but for these obstacles, which are modern and more present in the environment on a daily basis. So the robot understands that it can go through all these obstacles right now. How do we fix that? So instead of using something like this, we are also using now Intel RealSense to see what are the dynamic obstacles in the environment. So it throws the rays on objects like this with the LiDAR won't pick up. It projects those points onto the ground. So there's a big bounding box, and essentially your problem is solved. And you can give it a leeway radius so that it is safely navigating around the objects. So all these points are what the robot can navigate around. So that's our system that can also, of course, translate to other similar looking objects and essentially make it way more robust than it was in our SVD. So as for manipulation, we are using YOLO weird skill for object detection, which you just saw. And essentially, you just choose an object of interest. For graphs, we were using previously GraphNet, but now we have actually moved to a pattern system, which is using 3D bounding box around the object, and then it segments it into planes and chooses the centroid, and it gives us the grasp and the yard, which is supposed to grab the object. This is way more robust again because previously GraphNets, because of point cloud limitations, were a bit off. So this is giving us way more successful graphs. So you grab the object, you take it back, and you place it after detecting the plane it's supposed to place it on, which in this case today will be the square. That's our whole pipeline about how it works. What does our demo look like? Last time we showed you 3 objects: banana, apple, and water bottle. And we said that we'll add 7 more for FPD. We have finalized this. And today we're going to start with a solar panel, and a remote. And then eventually we're going to show you, if time allows, a mobile phone, a tie, and a shippable box. So that's mostly it. And the demo progress is on. We're going to see all these videos all this being manipulated in real time here. It's the time for the demo. Okay, let's go. Oh yeah, okay, let's start with Teleop. What do you think? Yeah. So this is the teleoperation thing I mentioned. This person. So currently we are on a video call with the robot. Over here you can see the screen, all of you over here. And then if I navigate, it can navigate. So I go back, it goes back, manipulate and bring the gripper up. It can do that. It can yaw the gripper as well, wherever I would want it to. So these are the teleoperation capabilities. We don't want to waste much time on this stuff. We're going to move ahead to autonomy real quick. So I'm just going to quickly end the call at the top. So it's going to go back to its autonomy mode. Hey, Alfred.
It's live.
Can you get me a teddy bear?
I'll do it right away.
So on that TV screen, you can see all these commands being parsed on the right visualization. So all these commands which Shivam just said and the robot replied with, and the task state is being showed in real time. So right now it's scanning for the teddy bear. Right side door. No, I think for the teddy bear.
You don't have that with, just having priorities.
Yeah, so it has a rough idea of where the teddy bear is in this environment, but once it gets to that rough location, it has to scan for the objects. Find stuff. Go to the teddy bear. You can also see the grass. Yeah. As a transform, found it really close to the center.
It always goes to the center. Not that bounding.
Yeah. Previously, we would use DAFNet, but due to point cloud limitations, sometimes it would be way off and our gas was not successful. So this time we are putting a 3D bonding box instead of using 2D bonding boxes to drive. That one brings the work some of that. But then the important thing is that we were previously not supposed to actually put deployment we want that this is going to be we also here like even if we do not according to your object, something so get there. So then so right now it's in the navigate to user stage. So it knows that in this rough area, there's a table which I'm supposed to place the object on. So it's going to approach it and place the teddy bear on the table. And over there, you can see all the bounding boxes in 3D that are being considered the obstacles right now. This teddy bear. You can see the plane on the visualization, right? So it has a move until contact feature, so it'll slowly go down. And the second it detects that a surface has been detected, it stops, lets go of the object and goes back. So now it knows that there's been contact. Releases the object. Like that, spaceless. If I let's do another command.
So if the table were a foot higher, it would be able to do just as well.
Exactly, because it just stops when it detects contact. Right.
Here you go.
Alfred? Hey, Alfred,
Oh, yes.
can you get me a TV remote? What is the TV remote?
I think robots typically don't use TV remotes, that's why.
Yeah.
Okay.
Yeah, sparse.
Okay. You're just thinking.
Network.
Hey, Alfred,
Yes,
can you get me a remote?
let me get that for you.
What is like in our previous stack, the robot was before it, so we cannot see it. And one of the improvements we made on this semester is adding 3 navigation capabilities. So, like Charles mentioned, it's also using the depth camera mounted on the head of the robot for navigating around and
So this one is pretty cool because if you see the remote has been placed at 90 degrees, so it's gonna actually yaw in order to grab the object.
also, one thing to mention, previously we couldn't traverse across the carpet. Because our localization was not accurate enough, but now since we are also using 3D navigation, we exactly know where the obstacles are in front of the camera, we are able to navigate across the carpet, and even if localization has a little bit. Still okay. Small request to you guys, but like, okay, right, like, constant, what is, and loaded. These are because of the network issue that we have. Connection over here.
It's the same problem that
We want to check the I think that maybe not be was in the data. Recently, what was I think it's almost real time reduced to one time.
Same.
How will you know it?
Router. Is a router.
What happened with them?
So, you want to explain that? Yeah, so essentially, like, we're having a lot of network problems, so, if I have a new Wi-Fi, what about money, like, high bandwidth information, so even if it's very high bandwidth, it's already compared in setting. So just for context, we use we have a GPU called the Alfred's Brain, which, the onboard computers are uploaded to the GPU for, so that's sort of the opportunity. That sort of shows when the, see the frame rate of the visualization and stuff.
Yeah, it's very jittery.
Hey, Alfred. Yeah.
Screen is on. Screen is on.
Hey, Alfred.
It's fine.
Oh, yes,
Can you get me a remote?
oh, nice.
Meanwhile, if you guys have any questions, you can always ask.
So as far as manipulation goes, what's the concept of the stuff that? So even if you need to ask it.
I think, so these objects, we have selected only required 1 degree of freedom, the calculator which is here, so that we can grasp it, but certain objects with complicated geometries we also need to pitch and roll in order to grasp them. Those are not possible with the current slate.
You have to ask him, you're looking for each axis and find the same height. Existing process from.
Yeah, so what it does is, it already has a pointing box and get the object point cloud. And on that object point cloud, it fits a tight 3D bonding box along with the orientations. So we know which is the long axis and which is the perpendicular axis, and we use it to find the value of the yaw, which with the chip shift captain. You can see on the object.
Yeah, maybe. So this is the move back recovery. So whenever the robot gets a bit confused, it goes back a bit and then follows a new path again.
And the confusion is localization.
Yeah, mostly. So if you see those orange AMCL particles around the robot right now, the more constrained they are, the more confident it is. So right now it's pretty confident.
With that, it's also takes remote. So let's try another object in the scene. So right. Hey Alfred,
You wait for it to finish.
He'll first say, here's your object.
Here's your thing.
hey Alfred.
It did.
Can you get me a soda?
I'll do it right away.
This time the location is different. First, we were sending it to, let's say, the kitchen area. Now it's the living room, supposedly. So get the soda from there.
And you guys said it's using ChatGPT or something like that in order to handle various number of descriptions of that object. Could be Mountain Dew, could be soda,
Exactly. Yeah,
could be pop.
it could be pop. Yes, indeed.
Pop.
Add to that, how many primitives we're using.
There are like 2,500 commands that Alfred can understand, and it tries to match what the user says with these 2,000 commands at runtime.
Yeah, I was gonna say, thank you for
Sure.
mentioning this because your first, I'm sorry.
Yeah, I think YOLO is again
So I think the frame rate on the
robot is.
the Wi-Fi is like loaded. Okay. So, any questions? Anyone have any questions on what's going on? How it works? As we get started. Is it like a dictionary where the object locations are stored, or is there some sort of search? Yeah, so we have a rough idea of where the objects are in the environment. When you say object to launch down. Okay, visualization, I think it's looking. I'm using that one. Probably for this. So I'm putting
Mm.
first part of it, it was displaying it. probably.
That was also saying Wi-Fi is the issue was there.
What conversation,
Yeah.
can you just say something about, the number of commands?
How many people stay involved? Yeah, so you want to talk about that? Okay.
About
How does the robot interpret commands?
yeah, so you have a string that represents what the user says, and then you perform string similarity matching. Like you compute a score for each primitive that you have in the database, and you select the string that is most similar to, and you then fetch the task name that's associated with that command. And then you execute it.
That is close enough, then we offer it to
ChatGPT.
Conversation. Okay.
And to answer your question, so once it knows where the object is, then it has a defined list of parameters. Like, okay, this is a location for this object, like the rough location, and then it goes and searches.
Yeah.
Oh, yes.
Give me a soda.
On it.
Stray soda can.
Currently, it's trying to do it is trying to align single tissue such that it's within the task. Searching for the object. It continues searching until it finds it. Seems to be we have never had such thing in this. So.
So in the video here, it seems to be picking up a single tissue. So
Yeah.
it doesn't pick up the whole box?
No.
How were you able to differentiate between the two?
We really don't like, we
Okay.
just go for the tissue paper and only one comes out. So that's like out of the design of the tissue paper box actually, but
Okay.
nothing magic there.
Okay.
And that is how rough estimate about the object's location beforehand. Yeah. So once you deliver it to somewhere, do you update that location that this has been moved to this location? Yes. Actually, that's a great point. That's one of the limitations of our system currently, that we have to manually specify where individual objects are. But as you'll see in the later part of this presentation, that we are gonna augment this capability for SVD on FPD on tour, where you can directly inference on the map where the objects are. For example, if you have a map, you can know where the tables are exactly, you can go directly there.
Grab it, I don't.
Yeah, I know.
We think that taking place like delivery robots in the future. So fancy. Yeah, not I. You think that a robot like this is gonna be in your houses in, let's say, 10 years from now? Okay. How about 15 years?
It's a wedding contest.
Yeah, the exception was you let it in after 10 years and you get sick of it and get rid of it at 15.
Life is open.
Nice.
Nice.
Okay, I think that was great. Maybe we could finish up with the information about Encore or whatever at the end of the presentation.
We
Yeah.
could do a tissue paper if you want, but we
Well,
could.
we only have about 4 minutes. left.
Okay, cool, yeah, that's fine.
One more object is close by, which is the after.
Okay, but while it's doing that, can we?
Yeah, we can do that.
So just give the command, I'll show.
Sure. Hey, Alfred.
I don't think it said here, there's.
Can you get me an apple?
I'll get right on it.
Okay. So we showed you the tissues and then the rest of the objects, teddy bear, remote, soda can. As for testing, these are our testing results. So we achieved 85% samples for HRI task interpretation, and the net map for Riolo was 0.815. Manipulation success is 70%. The requirement we set was 65. And manipulation speed, we set as 8 minutes to give a conservative estimate, but we are achieving it in roughly 1.5 minutes. And then the rest of the localization tests were also satisfied. So I'll quickly, skipping this part, move on to some gratitude we have for everyone here. So actually, first of all, starting with the person who actually manages the space, Greg Armstrong at the back. Can we have? He's been so cooperative with us, just coming every day here and disturbing his space, and he's been really helpful. So thank you, Greg. Oliver Cromer, without whom none of this would be possible. The both robots we have been allowed multiple times to test with it are thanks to him. And then, of course, our advisors, John and Dimi, through not just your courses, but continuous guidance throughout. It's been really helpful to put our efforts in the right place and get the best out of this project. And she's not here, but Sarah has individually helped all of us get really far in this project as well. And lastly, our advisors, Zachary, Jonathan could not be here. The best thing about them is that they let us really take the lead on what we want to do, and they guide us in that path the best way they can. They don't really try to micromanage us, and that's a beautiful thing about them. So thank you, Zachary and other friends. And lastly, this is the team. So,
No, this seems very good.
here is the offer. After the Thanksgiving break, next Wednesday here, 5:15, AI Makerspace. We're going to show you a much more enhanced version of the system. And that system will look, entail what our progress has been on the deployment front and the research front. On the deployment front, we have been talking a lot with Vincentian. It's Shenley Gardens Senior Living Facility in Pittsburgh. And they've been basically catering our use case so far and telling us this is what you need to do. So we're going to show you those capabilities. And essentially, we have mapped their environment already. We'll show you a video about a demo. And then this remote, which I'm holding right now, is actually going to alter the task, which Shivam is using his voice for right now. The rest of the stuff you'll see next week. As for research, as Abhinav mentioned, right now we are hard coding the locations. But what if we could have a map in which the location is already pre-filled, like this semantic information about an object being at a specific location. So that for that, we're going to use BL maps. And then lastly, 3D manipulation. So there's chances there might be some other objects in the environment when you're trying to manipulate the object. 3D manipulation can actually help you overcome that as well. So that's going to be featured in Encore as well. And yeah, that's it. Thank you so much for your time.
What was the result of the apple?
So what happened was actually is it went to the graph. It went in the object board while it was yeah.
Just didn't quite get it. Okay.
No, it did get it like, and then it like it's
Slipped out.
Slipped out, yeah.
Okay. Granny Smith and apples next time. Maybe. For sure.
Or use up there.
It is not the Wi-Fi, no? Can I ask what the software is?
The software, this is Video Ninja.
Video Ninja.
Let's start.
और थोड़े से पास की बात तो परसेंटेज निकालते हैं
अगर वहाँ मैचिंग नहीं हो रही तो
बहुत सारे ऑब्स्टिकल डिटेक्ट कर रहे हैं
It's by Wednesday, the grading.
No.
Okay.